Have you ever wondered where teams generate the amount of money to afford such big names like LeBron James, Cristiano Ronaldo, or Tom Brady? Well, today I would like to explain a two-variable analysis between team succession in the Barclays Premier League and each team's matchday earnings throughout the season. Now, I would like to begin by explaining the terms I will be using during the duration of my presentation. They are the BPL and matchday earnings. The BPL stands for the Barclays Premier League. It is a soccer league based out of England that creates the best players in the world. It contains 20 teams, all from cities inside of England, that each play each other twice, one home and one away, and hope to hold the BPL trophy at the end of each season. My second definition is matchday earnings. Matchday earnings is a generic category that consists of merchandise sales, ticket sales, even down to the last hot dog goes under this one number described as matchday earnings. The question I will be asking today is, does team succession impact matchday earnings throughout a season? I believe that the more successful a team is, it will positively impact their matchday earnings. The reason I believe this is because when your team is performing to an excellent standards, it attracts many different fans across the world to support that team in any way possible. Therefore, I also believe that there will be a strong correlation between the place of a team and their matchday earnings. The population and sample regions are fairly unknown due to the fact that the data collected is from around the world. My data is collected from each individual team. Each club is run like a business. Therefore, every piece of data that involves money is collected through a balance sheet. We will now look at each variable individually, starting with Season 1. Now, as the graphs show, the matchday earnings mostly range from 20 million to just under 40 million. This is shown in the histogram and dot plot. The histogram is positively skewed with the majority of the data in the 20 million mark. The quartiles are another indication of the range, Q1 being 16 million, Q3 being 43 million, and the mean at 29 million. This means that throughout the entire quartile, the mean seems to be just in the middle of Q1 and Q3. As shown in all the graphs, there tend to be multiple outliers at the far end of the graph. These outliers are there for teams that have great success throughout their season. The reason they are outliers is because not many fans care to support a team in the middle of the table. Therefore, this results in multiple cases of lower end matchday earnings. There are many measures of central tendency that can be used to calculate the average of this data set. The mean at 29, the median at 16, and the mode, which is shared with 5 teams at 8. The best measure of central tendency is the median, because the mean is affected by the outliers while the median isn't, and the mode is usually not used with numerical data. Now we can talk about the measures of spread. The measure of spread shows how the data is distributed along the graph. The measures of spread consist of the IQR, which is 27, the range is 94, and the standard deviation is 29. Unlike the measure of central tendency, these values are different and show different spreads. The IQR represents the middle portion of the data, showing how closely related the middle part of the data is to each other. The range is a spread from the maximum to the minimum value, and the standard deviation shows the difference in spread between each individual point on the graph. The best measure of spread would be the interquartile range, because it clearly shows how far apart the middle 50% of the data is from each other. This is very important when trying to describe these graphs. We will now look at Season 2 and its graphs. In Season 2, most of the earnings start at around 10 million and end just under 40 million. Also, not many points fall under the normal distribution curve. This is shown in both the histogram and dot plot. The histogram is positively skewed with quartiles Q1 at 9, the median at 15, and Q3 at 33. This explains that most of the data within that 50% is between Q1 and the median. Similar to Season 1, there are many outliers in the upper portion of the graph. They lie at 109 million, 93 million, and 71 million. These again are teams that performed extremely well during the duration of their season and had extraneous amounts of support. There are major gaps in this graph between the third highest earning at 71 million and the fourth highest earning at 43 million. This is possible because the team with 43 million is the only team in the league which is located in the same city as the club who won the title. Unfortunately, this negatively impacted the earnings for this team and resulted in a $28 million gap between third and fourth. There are many measures of central tendency located in these graphs. There is the mean at 28 million and the median at 15 million. The best measure of central tendency will again be the median, because even though there are only 3 outliers, they are significantly higher than the rest of the data, which increases the mean, giving a false measurement of the real average. The measure of spread can be measured in these graphs as well. The interquartile range is 24, the range is 105, and the standard deviation is about 30. These values all represent a certain type of spread. The interquartile range explains that from quartile 1 to quartile 3, the value is 24 million, which shows how close that 50% of the data is to each other. The range shows the minimum value on the graph to the maximum value, and the standard deviation, which represents an average of separation between 2 points on a graph. Although all these measures of spread are valid, the best one to use in this situation will be the interquartile range, because it represents how far apart the middle 50% of the data truly is. This also allows for predictions to be made about the 2-variable analysis. Now, I will begin with my 2-variable analysis, where I am comparing Season 1 results to Season 2. At the bottom of the graph, the equation says Season 2 equals 1.01 Season 1 minus 1.4 r squared equals 96. This means that if you average $96 million in the season, you will have a 100% chance of winning the title. The line of best fit has an extremely strong correlation between Season 1 and Season 2. This is because as the better the team does in a season, the greater matchday earnings they will receive. This graph has a high correlation coefficient as shown in the closely compacted data aligned with the line of best fit. The extraneous variables that impacted the data is human opinion. Now, you must be wondering what I mean by this. In England, for example, there are many die-hard fans, and therefore, no matter how poorly their team performs, they will still support them. This impacts the data because it increases the match-day earnings of some teams by more than the average. In conclusion, there is a correlation between team success and matchday earnings. This means that my earlier stated hypothesis that team succession will positively increase matchday earnings is true. The cause for my correct hypothesis is because as a team begins to perform at a high standard, this brings interest to the team apparel, game attendance, and players, which results in an increase to matchday earnings for that specific team. A possible extension for further research could be what is the team wage compared to team succession. The reason I would choose to research this topic further would be if a team is doing well, I would like to know if it is because they have fantastic players or is it because their team just plays well together. This would also bring into play the matchday earnings, because if a team has low matchday earnings, they would not be able to afford great players. Thank you for listening to my presentation, and I hope you enjoyed.